Welcome to 2.6 Part 2, Rational Functions and Their Graphs. We're going to continue talking about all the different rational functions and their types of graphs. Our essential questions are, how do you graph a rational function, and what real-world situation will I use this in? Always a good one for me. Basic reciprocal functions. So these are two reciprocal functions. You have an odd function, where f of negative x equals negative f of x, and it has origin symmetry, or you have an even function, which is f of negative x equals f of x, so it's y-axis symmetry. Alright, so an example using transformations to graph a rational function. Use the graph x equals 1 over x to graph g of x 1 over x plus 2 minus 1. So let's begin with f of x equals 1 over x. You have a vertical asymptote and you have a horizontal asymptote. It is graphed on here for you. You've identified 2 points and the asymptotes. So now we're going to start graphing g of x equals 1 over x plus 2 minus 1. Since the denominator became x plus 2, you're going to shift 2 units to the left, or subtract 2 units from every x coordinate. So every x coordinate you have, you're going to subtract 2 units. That includes your vertical asymptote. So your vertical asymptote is going to move 2 units to the left. And then each of your points is going to move 2 units to the left. You're going to subtract 2 from each one. Now, since you're subtracting 1 at the end, your graph is going to shift down 1 unit. That includes your horizontal asymptote. So you're going to subtract 1 from every y coordinate. So you subtracted 2 from every x coordinate and 1 from every y coordinate. And again, your horizontal asymptote is now going to be y equals negative 1. So it's the same idea that you did before with your quadratic. So a strategy for graphing a rational function can be used to graph f of x equals p of q, or p of x over q of x, where p and q are polynomial functions with no common factors. So first thing you want to do is determine whether the graph of f has symmetry. So does it have y-axis symmetry or origin symmetry? Then find your y-intercept, if there is one, by evaluating f of 0. Step 3 says find the x-intercepts, if there are any, by solving the equation p of q equals 0, and find vertical asymptotes by solving the equation q of x equals 0. 5. Find your horizontal asymptote, if there is one, using the rule for determining horizontal asymptotes that we talked about last class. And 6. Plot at least one point between and beyond each x-intercept and vertical asymptote. And finally, 7, use the information obtained previously to graph the function between and beyond the vertical asymptotes. So, step 1 says to determine symmetry. So we're going to do f of negative x equals 3 negative x minus 3 and negative x minus 2. Negative 3x minus 4 is 3, negative x minus 2. So not everything switched, so you have f negative x does not equal negative f of x. And the next one you want to do, well, you can also see that f of negative x does not equal f of x. So when you plugged in negative x, it didn't turn everything the opposite, and it also didn't stay the same. So there's no origin or y-axis symmetry. So you know there's no origin or y-axis symmetry. So go on to step 2 and 3. Step 2 says find the y-intercept, so evaluate f of 0. So we're going to have 3, 0 minus 3, 0 minus 2. So you have a y-intercept at 0, negative 3, negative 2. Now to find your x-intercept, this means you're going to have 3x minus 3 equal 0. This means you have an x-intercept at 1, 0. Now move on to step 4. Step 4 says find the vertical asymptote. If you remember back to last class, we find our vertical asymptote by finding out what makes the denominator 0. So we have a vertical asymptote at x equals 2. As we're going through this on a piece of graph paper or on your homework, that's when you start graphing it. So as we go through, you put your dots at your y-intercept and x-intercept, and your vertical asymptote, you draw your dotted line. I don't have the graph over here, but that's what I would be doing. So step 5 is find your horizontal asymptote. So in order to find your horizontal asymptote, you have to take n, which is 1, and m, which is also 1. This means you have n equals m. Remember, when you have n equals m, you need to take your coefficient of both and divide them. So you have a horizontal asymptote when y equals 3. So at this point, I'm going to put all of this information together. So we're plotting the points between and beyond each x-intercept and vertical asymptotes. So your x-intercept is 1, 0. Your y-intercept is 0, 3 over 2. And then you have a vertical asymptote, x equals 2. And you also have a horizontal asymptote at y equals 3. But we'll add that part in a minute. So, step 6, so we drew our points and plugged in our parts. Now, you have step 6 that says plot points between and beyond each x-intercept and vertical asymptote. This means we're going to pick points between and beyond each x-intercept and vertical asymptote to see what our graph does. So, I picked out points for you. So we're going to evaluate when x equals negative 1, 1 half, 3 halves, 5 halves, and then 3. So I'm going to have you work on this, pause the video and work on it, and then we'll go over what the answer is. Alright, you should have paused your video, and now we'll go over the answers. So at negative 1, you should have gotten 2. At 1 half, you got 1. 3 halves, negative 3. 5 halves, 9. And 3, 6. Now you want to go in and mark those points on your graph, and now draw in your horizontal asymptote. So I have all of my points marked, and you have your graph drawn. Make sure you complete the questions below and watch the next videos. Next video, we'll discuss graphing rational functions and a slant asymptote.